Yeah.
And what I have up here are my notes on the right side. And then this is the section of the handbook, the FE reference handbook. It's just a few pages related to ethics, and most of it is the code of ethics, and talks about what the code is. And then there's a model code. This is a code written by NCEES, and is used as a sort of a standard against which other engineering organizations compare their own codes. So it's sort of trying to be a model that professional organizations can follow. And so on the FE exam, some of the questions might just relate to content in the model rules. And so the thing to do is just know where to go. This is the very first section of the FE reference handbook. So you just see what the question is and look it up in this section of the handbook, the model rules, and there's some definitions. So these are what is an engineer, and definitions of practice of engineering, an engineering intern, and so you might want to just skim this at some point. And some general requirements for licensure. So you just might get a multiple choice question that asks something related to what's in the model code here. Grounds for disciplinary action. That's longer than I remembered. And definitions of intellectual property. So you might get a question about how long a patent is valid for in the US, or when would you apply for a patent versus a trademark versus a copyright. What is sustainability, definitions of sustainability, and how that applies to engineering work. And that's it from the handbook. So in my own notes, there's not much here because it's difficult to prepare for the ethics part, other than to say, here's what's in the reference handbook. Just have that handy and look stuff up as needed. Some of the topics, and so you're not going to get questions about utilitarianism or Kantian ethics or things like that. That's not what we're talking about here. This is practical application of ethics in our engineering work. So the NSPE Code of Ethics, and maybe some questions about law and professional practice. Questions about contracts and professional liability. Now these, you might get a question that's not in the reference, but it's in the study guide. If you go into the ethics and professional practice in here, you'll find some information about contracts, what are contracts and when are they enforceable, professional liability, ethical obligations, and some of these questions can be long. They can give you a scenario and ask you what the ethical decision might be for the particular case. So you might get something, this wayward Professor Collins was doing engineering work, and while he was bidding on a government contract, he was accepting money from a foreign government, and it's just this story of what the engineer is doing, and then ask whether the engineer committed an ethical violation or what the ethics violation was. Conflict of interest is a big one. So as an engineer working, I should not receive gifts, or I should not accept gifts from suppliers that I purchase from. The suppliers often, give you things like little instruments. I used to have pressure gauges and really nice pencils, and the little wheels that we use, like an HVAC, to the ductulator to find friction loss given velocity, things like that for water flow. And vendors kind of give these things to you in hopes that you'll remember them and consider them when you need to purchase something. And from an ethical standpoint, we really need to be careful about accepting things like that. And we certainly should never be accepting money when that money, there might be strings attached. And the thing here is, it isn't just whether there's strings attached. Somebody gives me money, and in return, I will sign a drawing. Man, that's a big no-no. But you can get in trouble even if there's an appearance of a conflict of interest. Like somebody does me a favor without any expectation that I'll give them special treatment, but it just doesn't look right. So there's what's called the appearance of a conflict of interest. And we need to be careful about things like that. So you can see questions or scenarios where those kinds of things come up. And then there's some example questions. Oh, wait a second. Oh, okay, yeah. So an engineer working for a big design firm has decided to start a consulting business, but it'll be a few months before she leaves. How should she handle the impending change? The engineer should discuss her plans with her current employer. The engineer may approach the firm's other employees while still working for the firm. The engineer should immediately quit. The engineer should return all the pens, pencils, and blah, blah, blah. So you're like looking at this and going, gosh, what in the world here? Maybe it could be any of it. Some of these, it just may not jump out at you what the answer might be. Some of them, it will. Now, for this one, let's see. What do you think the answer would be?
Inform them, but they can fire you if they want.
Yeah. The answer is A. You should be upfront. And this is a general rule of thumb, is to always be upfront about things like this. Also, would be a situation where you might take a part-time job. Maybe, as a PE, you do some consulting on the side, and while you're working for Boeing or whatever, but you need to be clear upfront with Boeing that, look, I'm doing this. Are you okay with it? So being above board in our activity. An engineer employed by a small bridge design firm has given a large donation to a public.
Doesn't look motivated at all.
This public official happens to be a key player in the decision to fund construction of the bridge. This is Professor College. Which section of the model rule does this violate? Licenses is his obligation to the public, to other licensees and employers and clients. Obligation to uphold engineering etiquette. So this, you might thumb back through the model laws in the reference handbook, and do you know what? Can you guess what this might be?
C.
B?
No.
What was it?
C.
C?
A or C?
God, I can't remember. Actually, I think it's B. I think it's obligations to other licensees, because by doing this, by giving money, you're putting yourself in an unfair position vis-a-vis other engineers that might be competing for the same opportunity to do this work. And so I think the answer here is B, but I'm not 100%. I think it's B. We should check that. Okay, an engineer at a large automobile manufacturer is designing a new steering system. While studying the production line, she discovers a defect in the steering system being produced. After thorough analysis, she concludes the defect has a high likelihood of causing catastrophic failure with serious injuries. What should she do? First, inform her company's management. Then notify the National Transportation Safety Board, inform her supervisor, and resign if the company doesn't implement a new design. Continue to follow the company policy of selecting the most cost-effective design. Send an anonymous note to a local radio station and ask that they publicize the company's failure. This is a case where you can probably rule out. I think we can rule out D. And we talked about this in Citizen Engineer, right? That this is a whistleblowing situation, but whistleblowing is really a last resort. It's not a first resort. You don't wanna jump, my employer's unethical, is a scoundrel, is killing people. You wanna exhaust all of the channels within your organization first, starting with your immediate supervisor, right? So I think, let's see, C and D we could rule out. How about A or B?
I think it's A.
Yeah, it's gonna be B. Why do you think it's B?
A is over escalation.
A is an escalation, an unwarranted escalation, because you might notify the National Transportation Safety Board after you wait to see what your management does. You wanna give your supervisors a chance to respond before you go outside. Yes, sir?
Wait, but if you tell your supervisor and the supervisor doesn't do anything, then shouldn't you go, not just resign? Oh, wait, no, that doesn't, never mind.
Yeah, see, the problem with that, what would be the problem with that? You didn't fix the problem, right? You didn't notify anybody, so people could still be injured or die as a result of this failure because you just quit and ran away from the problem rather than pursuing it, right? So, yeah, these could be. Which statement is true regarding the legality and enforceability of contracts? Mutual agreement of all parties must be evident. The contract must include purchase order. The contract to perform an illegal activity can still be enforced by a court. A contract must be in writing to be enforceable. Which of these is true, a true statement? The answer is A. Now, the first impulse, I think, of a lot of people is D. You must have something in writing. But actually, in the US, if somebody can prove that we had a verbal understanding, a judge will actually accept that. Even if there's nothing in writing, if you can prove that there was a serious verbal understanding between you and the other party, that can still be enforceable. But the burden of proof will be pretty high. You have to show that there's there's communications, a trail of communication that would lead a neutral party to think that, yes, you do have an agreement here. So A would be the answer. Mutual agreement of all parties must be evident, even if there's nothing in writing. What is the term of a patent issued in the US? Did you talk about that in your
20 years.
20 years? Yeah.
Application.
From
It's from Amazon. And you can get like the 1 year extension.
It's from the date of application. From the date of application. This is a change from, I think this was made about 15 or 20 years ago. It used to be 17 years from the date of issuance. But the change to 20 years from the state of application makes us more consistent with other countries' patent systems. And here's one we just kind of touched on. When can a project team leader sign and seal a design prepared by a member of the team? The team leader is a licensed PE, whether or not the team member is licensed. Both the team leader and the team member are licensed, and the team member, but not the leader, is a subject matter expert. The team leader is a licensed PE who is a subject matter expert, and the team member is a direct subordinate of the team leader. Or never.
See?
Yeah, you might think D, never, because in fact, I'm almost, I mean, I would never want to sign something, a design that someone else did. I would just really feel uncomfortable, even if that person was my direct subordinate. Well, yeah, that's a tough one. I just like to do my own work. I haven't been in that situation, but yeah, the answer is C. The team leader is licensed, so the person stamping must be licensed. The person stamping must be a subject matter expert. So if I'm licensed in HVAC, I should only be stamping HVAC work. It should not be electrical or civil or something like that. And the person that I'm signing for must be under my supervision. Okay, it should not be somebody that's unrelated. I should be in responsible charge of the work that's being done. So it's a pretty steep set of requirements there. So that's an example of some of the questions, 4 to 6 questions you might see on the ethics part. It's really hard to study for, other than having that, knowing where to go in the handbook. Okay? A much more substantial part here is the economics. And because this is probably going to be new to me. Have any of you had an engineering economics class? I'm not sure if they offer them or how common they are at other colleges. So again, a small section, 4 to 6 questions. The FE Reference Handbook has about 8 pages of information, and the topics covered. And the way I organize my notes here is I talk about the time value of money, evaluating investments in projects, and the final is depreciation, is depreciating equipment that we invest in, we purchase. Those are the big 3 pieces. There's more, but I think this covers the main areas of questions that you can expect. So time value of money. This gets at the point that money today is worth more than money in the future, okay? If you think about, someone gives you a choice. I'll give you $100 now, or $110 next year. What would you take? $100 now or $100 in 1 year?
I'll take $100.
I'll take $100 now.
Yeah.
How much would I have to give you next year to make you choose to receive it next year?
Double, probably.
Huh?
Double the price.
Double. Okay, so you would take, I would have to give you $200 next year to give you an incentive to take that, as opposed to receiving $100 now. Okay, so that's an indication of the time value of money. That's your discount rate. Your discount rate is you need double the amount that I would give you today. And this gets at the heart of time value of money. Looking out to the future, we just see money losing its value over time. And also money loses its value because of inflation and the economy. And the other thing with the time value of money is risk. Now you might say, yeah, I'll take $200 next year, be happy, but you would also have to factor in risk. What if I had cancer? Maybe I have terminal cancer and I'm gonna die. I may die in 3 months. The doctor gives me 3 months to live. That $200 sounds great, but maybe you didn't know that I might not be around. So there's a risk, you see? There's a risk when you say next year. There's a risk I might not be here. Earthquake could happen. Lots of things could happen that would affect that. So you might say, oh wow, yeah, I forgot about that. So I want $300. It's gonna have to be $300 to forego getting $100 now. You're taking into account the risk, and that all goes into the time value of money. And all of that risk and the discounting is captured by the interest rate. This is the, you know what interest rates are. This is the cost of borrowing money with the promise that we're going to repay it over some period of time. And in engineering, we often purchase very expensive machines and infrastructure and things like that we have to borrow that money somewhere at an interest rate paid back over a period of time, often 20 years, 30 years for energy infrastructure or HVAC infrastructure. And we'll borrow $100, pay it back at some interest rate over that period of time. There are different kinds of interest rates, and we need to know what these different interest rates are. But the big one here is the effective interest, or actually it's the effective annual interest rate, which is the interest rate that compounds yearly. Okay? But sometimes you might get offered a financial product where the interest rate compounds. The interest rate is on a monthly or a quarterly, gosh, even a daily basis. And if we're going to do comparisons of different investments, we need to normalize the interest rate to a common value. And that's what this effective annual rate is. And there's a way that we can convert that. For example, if a financial institution pays 6% interest every 6 months, the nominal interest rate, is 6% times, it's every 6 months, so 2 times a year, or 12% per year. So that will be the nominal interest rate, but that's different from the effective annual interest rate. The effective annual interest rate would be calculated using this formula here that allows us to go from the nominal rate R divided by the period, which would be 2 in this case, and that would convert the nominal to an effective rate. And in most calculations, we're going to want to use the effective annual interest rate. And there's some examples here of how we do calculations with interest rates. Individual sets up a retirement fund, deposits $20,000. How much will you have after 20 years if the interest rate is 6% compounded annually? So it's an effective annual interest rate. And so I, 6% per year, and N is the number of periods of compounding, which would be 20. And what we're interested in here is the future value of that investment. The current value, we call that present value, we give it a P designation, P. And we're interested in finding out the future value of this present amount of $20,000. What we're doing here is it's called equivalence. We're taking money at one point in time and trying to figure out what the equivalent value would be in another point in time. Okay, so at 6% annual interest, $20,000 today is equivalent to $64,140 in 20 years. Okay? 20,000 today, 64,140. In other words, if my personal discount rate was 6% a year, and somebody said, Professor Collins, I'll give you $20,000 today, or I'll give you 64,140 in 20 years, what would you take? And if my discount rate was 6%, I'd say I'll take 64,140, not a penny less. But of course, I'll take more than that. But that's my personal discount rate. That's what that means. This is equivalent today, the $20,000 today. Or another way to look at it, $64,000 20 years from now is equivalent to $20,000 today. Okay? Now, working these problems, many of these problems can be handled just by learning this terminology here, how to calculate the value of an investment or the value of money at different points of time. Here, we're given the present value, and we want to calculate the future value. The easy way to do this is to look up what's called an interest rate factor in a table, and the tables are by interest rate, and the notation here is we want the future value given the present value. At a 6% interest, 20 years is the period, and we look up this factor, 3.207, from the interest rate table, and the tables are in the reference handbook, and then we get the factor multiplied or given by the factor, and that gives us the future amount. So if we go to the handbook, So the economics section, it begins with a table that defines all of these factors that we use. Okay, you may have, well, see, the one we just did, we were looking for the future value given the present value. So that was the factor we looked up, but we can also just use an equation. And it's a simple equation in this case. We multiply the present worth by 1 plus the interest rate raised to the 20th power, to the n power. Some of these other factors are more complicated, hence the tables are more convenient. One thing we might be interested in is, if I have $20,000 now, what would be the equivalent annual amount of money paid out over 20 years that would equal $20,000 today? Okay, so my choice is accept $20,000 today, or every year for 20 years receive the same amount of money. What would that amount be? That calculation would be A is annual worth or annual value, A given P. So I would want to convert to A given present values. There it is. Convert to A given P. So my factor is A given P at whatever the percent was, 20 years, and that's the formula. But the formula is complicated, so it's easier to just go to the interest table, which the interest tables are here at the end. If I go to 6, they just give it to you for a few percentages. If I go to 6%, you can see all the factors are listed here. So if I wanted A given P for 20 years, so this is in 20 periods, and then I read over to which factor I'm interested in. Let's see, I want A given P. I come all the way over here. So I'd multiply 20,000 by 0.0872. And that amount would be an equivalent. And it would be spread out equally over 20 years. That would be equivalent to $20,000 now. Okay, so any of those factors I can look up in the table here. And so the handbook has the equations. Sometimes we need to use the equations. For example, if we have an interest rate that's not included in the tables. And then the definition of all the variables here. The expression for converting from the nominal interest rate to the annual rate, break-even analysis, how to take inflation into account. You can produce an adjusted inflation rate that's based on, that takes inflation into account, depreciation formula, and book value, taxation, capitalized cost. Capitalized costs are costs of investments that are perpetual, where you expect the item to be around forever. So this is used for like roads or bridges where you're gonna build them and you expect that they're gonna stay in useful life for a long time. Usually if it's longer than 30 years, that's considered to be perpetual. Bonds, that's kind of a minor part. Rate of return, calculating the rate of return and benefit cost analysis. And then a method that we use for depreciating capital equipment. The MACRS method allows you to depreciate non-linearly. You depreciate much more in the first few years of the life of the equipment, and then the amount trails off over time. And the reason why businesses like the MACRS is it gives them tax advantages early. You get the biggest write-offs on the investment early in the life of the equipment rather than later. And then the factor table. So it's not a whole lot of stuff, but if you haven't had a course in using doing these calculations, it's gonna probably take some time to get familiar. Okay, so my notes here just give some examples. Here's one, a bank charges interest on a loan at an interest rate of 24%. Man, that's a lot. Compounded monthly. What is the effective annual interest rate? So here we're going from a nominal rate to an annual rate, where the nominal rate is gonna be, it's 24%, so 0.24, and it's monthly, so there's 12 periods here. N is 12 months in a year. We're going from nominal to annual, so we use the formula plugging in 0.24 and 12, and we get 0.268. So this is equivalent to an annual interest rate of 26.8%. And then if we were doing calculations of annual or future value, we would use 26.8%. Okay? Now really what we're most interested in doing as engineers is figuring out how to evaluate the cost of what we want to buy to our company. And we do that by creating a cash flow diagram. And a cash flow diagram looks like this, where we would have now, 0 would be today, and then we go out successive periods for the life of the project. Usually this would be years, 1 year, 2 year, 3 year, 4 year, 5 year. This is a 5-year project. We invest $6,000 up front, and every year we're gonna have to pay $210 to maintain this investment. So maybe we purchased a machine. This is our expected annual maintenance on that machine. After 5 years, we're gonna get rid of it. We're gonna sell it at a salvage of $2,300. So you might wanna know, okay, what is, this is my cash flow over the life of this investment. What is the value? I wanna know a value at one point in time. Don't show me a bunch of numbers. This is what your boss is gonna say. Tell me now, what is the value of what you want to do? What is the value in today's dollars? So you want to calculate the present value of all of these flows of money. How do you do that? And that's what this problem is about. And this is I think would be a common problem you would see. A computer with a useful life of 13 years has an initial cost of $6,000. So there's our $6,000 initial cost, salvage value $2,300. An annual maintenance of $210. The interest rate is 8%. Now, where does that 8% come from? Now, a lot of companies, especially larger companies, will have an internal interest rate that they use to evaluate investments. This is called the minimum accepted rate of return, the MAR. You'll see that term, MAR, M-A-R-R, minimum acceptable rate of return. What is that? What that says is, let's say I'm Amazon. Amazon has a lot of money, retained money sitting around. What do they do with it? They put it into savings. Maybe they own bonds. They have investment instruments where they park their money. Those investments will be earning interest. That interest is Amazon's MAR. It's minimum acceptable rate of return. So what your Amazon bosses will say is, all right, Steve, engineer, you want to invest in this computer, and this computer might save me money. Actually, in this case, this is a cost. Sometimes you have to invest in stuff even if it's a cost, because you've got to replace things, or you need an infrastructure to start your business. But at other times, you're investing in something because it's going to return income, right? It might save you money. It might save maintenance. Maybe your existing machines, it costs you $400 a year to maintain, but the new equipment will only cost you $100 a year. That would be a net benefit of $300, and it would be a plus. It would be an arrow pointing up. Okay? So your boss would say, all right, Steve, I see what you're saying. We're paying $200 a year to maintain something, and or we're paying $400, and you've got an idea where our maintenance costs will go down to $200. Does So that's a net $200 benefit. It's gonna cost $6,000 today, and we're gonna have a cash flow of $200 every year for 5 years. Then your boss will say, all right, show me that that investment will return a benefit greater in value than what I can get just by keeping my money in the bank. Well, what are you earning keeping the money in the bank? 8%. Show me that your investment will return me 8% or more, and I'll give you the money to buy your equipment. Okay, so that's what you have to set out to do. And that's a big part of how we apply this methodology in engineering. Now, this is a situation where, well, actually, we could have, well, no. This is mostly cost, and then we scrap it at the end. But we want to know, okay, what is this worth today? In my MAR is 8%. Present worth, okay, the present worth. So here's what we have. We've got a negative $6,000 now, and then negative $210 every year for 5 years, and then a plus $2,300 at the end of 5 years. So we want to do, bring all the costs and benefits to time 0. Well, this one's already at time 0, so we don't have to do anything with it. But the other ones, the 210, the 2,300, we've got to bring these numbers to now. To convert the annual payments, we use P given A. Our A is 210. We want to bring it to the present, so P given A at 8%, at the interest rate here, 8%. At the end, we've got $2,300 of income. That's F, future. So we want to use a factor of P given F. We want to bring future $2,300 to a present number. And then our total present today's dollars is that initial $6,000 plus the present value of the maintenance plus the present value of the salvage. And what we do is, oops, I'm out of time. We look up the factors. This is how we set it up. $6,000 is already present. The 210, we bring that to the present by looking up the P/A factor in the table, and then 2,300, similarly, we look up the factor in the table, and we multiply, carry out the sum, we get negative 5273. So this entire cash flow, starting with the present investment, and then 210 paying out a year, salvage at the end, is worth in today's money, negative 5273. This is a total cost to me in today's dollars of negative 5273 at my discount rate of 8%. Okay? And so I'll stop here and urge you to continue to read on and some more examples. But before you go, I do have some practice for you.